It is my pleasure to welcome you to the fourth part of the crash course Foundations of Quantitative Research. This lecture deals with research designs. More specifically, I would like to explain experimental designs, longitudinal designs, and cross-sectional designs. To understand these, it is a good idea to understand the possible relationships between variables and constructs. If you have watched the first lecture of this crash course, Philosophical and Theoretical Foundations of Empirical Research, you will remember that I told you there what we're doing in quantitative research, and that is we're testing theories. And theories consist of constructs, variables, and their relationships. These relationships, the possible relationships in this context, you can see here. We might have a bidirectional relationship. In a bidirectional relationship, two variables are associated, but we cannot say that one variable affects the other variable. Statistically not entirely correct, but you can think of this as one variable is the cause, and the other variable is the consequence or the effect. For instance, work satisfaction and work dissatisfaction might be associated. If I have a high work satisfaction, I have a low work dissatisfaction. Or the other way around. If I have a high work dissatisfaction, probably have a low work satisfaction. We cannot say that work satisfaction is the reason for having a high or low work dissatisfaction, or the other way around. A higher or lower work dissatisfaction is the reason for work satisfaction. That's what we cannot say. What we can say, plausibly and logically, they might be associated, there might be a relationship. In cases when we can say one variable or construct has an impact on another variable, we're talking about unidirectional relationships. So we have an independent variable that affects a dependent variable. For instance, work satisfaction affects organizational commitment. If I'm highly satisfied with my work, I'm normally very much committed to my employer. If my work satisfaction is low and I'm thinking of getting a new job somewhere else, then I'm normally not very much committed to my employer. That means the independent variable of work satisfaction has an impact on the dependent variable of organizational commitment. Such a relationship might be mediated. In a mediated relationship, we have an independent variable that has an impact on a mediator variable, which in turn affects a dependent variable. The mediator variable mediates the effect of the independent variable on the dependent variable. For instance, we have a human resources measure, like higher pay, cycle to work scheme, I don't know, whatever you have there. This human resource measure affects work satisfaction, and work satisfaction in turn affects organizational commitment. This means, for this example, the relationship of a human resource measure and organizational commitment is mediated by work satisfaction. There might be also moderated relationship. It is again, we have an independent variable like work satisfaction, which has an effect on a dependent variable like organizational commitment. And there might be a variable, for instance, company size, that moderates this effect. In a sense, it depends if I'm working in a small, medium, or large company, how strong this effect of independent variable on dependent variable is. Perhaps in a small company, the effect of independent variable on dependent variable is stronger than a large company, or the other way around. And of course, we have nonsense correlations. You can statistically show that the population of storks and the birth rate in the south of Sweden around 1900 is related, is associated, there's a correlation. But of course, this is nonsense. We all know by now that the tiny baby children are not brought by storks. The reason for finding the statistical effect is not because there's a relationship between storks and the birth rate, but the reason is the industrialization. Because of the industrialization, the places for building a nest for storks decreased. So there are fewer opportunities for storks to build their nest. Furthermore, with the industrialization, the family size shrunk and the birth rate went down. And in this context, I would like to mention, for both data collection and therewith the research design and the analysis, the statistical analysis, these are all tools. It's better to understand quantitative research on the side of data collection and then on the side of analysis as a toolbox. And this toolbox can only be as good as you are correctly applying these tools. So think of this using an analogy. You want to get a nail into a wall. The best tool for this is not a screwdriver. It is a very good idea to use a hammer for this. This is what you can apply to all the instruments and methods in quantitative research. Let's go to the research designs, and I would like to start with experimental designs. The epistemic goal of experimental designs is to test a causal relationship between an independent variable and a dependent variable. And of course, you can have more than one independent, more than one dependent variable. So we ask ourselves the research question, does an independent variable have an effect on one dependent variable, again, one or more? And you can think of this like the crazy professor in his laboratory. He gives a mouse a difficult task, and at the end of the task, he puts a piece of cheese, and then wants to find out if the cheese, the food, can drive the mouse to solve this task. We have the independent variable cheese, and we have the dependent variable solving whatever task this crazy professor gives the mouse. And the simple setting and the simplest form, the setting of an experiment consists of an experimental group and a control group. You have then the manipulation, that is, if you will, the independent variable. You expose your experimental group to a stimulus, like I've just given the simple example of the cheese with a crazy professor. And you have a control group which does not get a stimulus. And then you measure if the outcome, the dependent variable, is different between experimental and control group. The bottom as a figure, you have experimental group and control group. The experimental group gets stimulus. For instance, you show an advertisement. And then in both groups, the experimental group, who has seen the advertisement, and the control group, which has not seen the advertisement, you measure, for instance, the brand image as a dependent variable, and then you compare these two. And if the brand image is better with the experimental group than with the control group, it's plausible to assume that your advertisement worked. So that is the simplest form of an experiment. Now I'd like to go in a bit more details. What is actually a real experiment? So the purest form of an experiment. And with an experiment, you have two objectives. You want to minimize the influence of environmental factors, and you want to minimize the influence of personal factors. Again, we want to find out, think back of the objective of experiments, we want to find out if an independent variable, a stimulus, has an effect on a dependent variable. for minimizing the influence of environmental factors, we have laboratory, or we strive after laboratory conditions. No influence from the environment. Again, think of the crazy professor who's in the basement of his laboratory and there's no external influences. So we keep the environmental conditions constant. To minimize the influence of personal factors, we must have homogeneous samples for the experimental group and for the control group. So the experimental group, the participants in the experimental group, and the participants in the control group must be similar. And this is what is normally achieved through a randomized allocation of participants to experimental and control group. Like tossing a coin, and whatever comes out, this person goes to the experimental group or to the control group. That has a pure experiment, if you will, a real experiment. This setting, minimizing the influence of environmental factors to laboratory conditions and minimizing the influence of personal factors through randomized allocation of participants to experimental and control group, has an effect on validity. Again, if you can remember and have watched the previous lecture of this crash course, there I shed a bit more light on validity and in particular on internal and external validity. Internal validity is the explanation of the dependent variable only through the variation of the independent variable. So only the independent variable has an impact on the dependent variable, and there are no other external factors influencing the dependent variable. External validity means I can generalize my results to other persons, other situations, other times, and so forth. If I have such laboratory conditions and the randomized allocation of participants to external experimental and control group, in other words, homogeneous samples in both groups, I have a high degree of internal validity. I can say it was only the stimulus, it was only the independent variable that impacted the dependent variable. But we're not living in such sterile environments. Thus, the external validity is rather on a low level with pure experiments. But you do not always have such pure real experiments. You might also have, and arguably more often than not, you have just experimental approaches. Then you have a quasi-experiment. For instance, a field experiment. You just, through an online questionnaire, for instance, you ask people about their brand awareness, brand image, who have recognized and realized or seen an advertising campaign, and others who did not see or were not in contact or cannot remember this advertising campaign. That would be called a field experiment. That means the internal validity goes down. There might be other influences from the real world that shape the dependent variable. For instance, from this example, the brand awareness or the brand image. But the external validity, we are in the real world, goes up. Now finally, I want to show you the hardcore experimental setting, if you will, the ideal experimental setting, and that is called the EBA-CBA experiment. EBA stands for experimental before and after. CBA stands for control before and after. Again, we have an experimental group, EBA, we have a control group, CBA. Let's assume, for example, we want to measure exactly what I've just told you. Does an advertisement have an impact on brand image? So we measure EB, experimental before, we measure the brand image with the experimental group, CB, control before, we measure the brand image with the control group, our dependent variable. Then we give our experimental group the stimulus. We show them the advertisement. The control group, nothing is shown, they don't get the stimulus. And then comes EA, experimental after. Now we measure the dependent variable again. In our example, the brand image with the experimental group. And CA, control after, we measure the dependent variable, in our example, the brand image with the control group. Let me give you real numbers. I just made up numbers. Let me explain this by numbers. Assuming we have measured the brand image on a scale from 0, not good, to 100, very good. Now we measure with the experimental group a brand image, a score of 70 before we give the stimulus. The control group, we measure a brand image of 68. And stimulus for the experimental group, no stimulus, no advertisement for the control group. And afterwards, we again measure the brand image. Let's assume for the experimental group, we measure 81. For the control group, we measure 72. First step you're doing, you're calculating EBA, experimental after minus experimental before. That's 81 minus 70, that equates to 11. The same step for the control group. Control after minus control before. That is 72 minus 68. That will equate to 4. Then, in the third step, we calculate EBA minus CBA. 11 minus 4 is 7. Now we can see the brand image improved better or more with the experimental group than with the control group. Happy days, we have an advertisement that actually works out. That is the principle. Of course, I need to mention that you also need inferential statistics here, which I will introduce in the last section of this crash course. But just the numbers here, I think, can give you an idea how an EBA-CBA experiment works. The next research design that I would like to introduce is longitudinal designs. The objective of longitudinal designs is measuring the development of a variable over time. And of course, we're in academic research. Normally, we look at effects at relationships between variables. So of course, it's also the development of effects over time. You can think of this, we want to find out if our education system actually works. So we measure the skill set and the knowledge that our pupils have when they go to primary school. Then we measure this again when the pupils leave primary school and go to secondary school. And then we measure this again when they leave secondary school, go to A levels, and so forth. So we measure over time to see, did the skill set, the competencies, the knowledge of our young people improve over time. We have two approaches how you can do this. You have a panel approach and a trend approach. In a panel approach, you ask the same people the first time and at the second time. A trend survey, you do not ask the same people, but the samples are similar. Perhaps this figure makes this clear. We have 2 points in time when we're measuring, T1 and T2. With a panel approach, we have the same people. With a trend survey, we ask one sample that should represent a population, and that is similar to our second sample, but it is not the identical people. Both approaches have advantages and disadvantages. One might argue with a panel survey, as we have the same people, identical people, at T1 and T2, we can measure real changes within these participants. But on the downside, we might face a panel effect. Everything you measure, you influence. It doesn't matter if it's social sciences, if it's physics, whatever it is, you influence. This can also happen in quantitative research and social sciences, and in particular, it can happen with panel surveys. Just think of a typical question from market research. Which of the following brands do you know, even if only by name? And then you list the brands, brand A, B, C, D, and the participant said, yes, I know, I don't know. Now that's what you're doing at T1. Then at T2, you ask the same question. Which of the following brands do you know, even if only by name? And they say, yes, brand A, I know. Of course, the last time when we had the survey, you told me that there's brand A, and I just need to know the name. So you have influenced your participants, and this can be with the same people, can result in the panel effect. On a trend survey, of course, there's no panel effect. You're measuring constructs with different people who are just similar, but they're still different people. The problem might be, not necessarily, but the disadvantage might be that you have a different structure in your two samples. So you cannot really compare the two samples if in sample 1 you have 80% female and 20% male participants, and then the next sample you have 20% female and 80% male participants. So this might be a problem for a trend survey. Let me give you an example how such longitudinal studies look like. That is from a publication I could realize with 2 co-authors, and it is about the fulfillment of the expectations and their fulfillment, customer expectations and their fulfillment in the German food retail market during the COVID-19 pandemic. So my co-authors and I ask ourselves, did the customer expectations and their fulfillment in the food retail market change during the COVID-19 pandemic? We collected data in March, April 2019, and then 2 years into the pandemic, March, April 2022. We had a good degree of representativity with the sample. In total we had 1,202 in our first sample, and then in our second sample we had 1,108 participants. And you can see in the age brackets, male, female, the distribution. Both samples are rather similar. So we can, even those different people, we can compare them. And this figure in the middle here, this is how the results might look like. Here's the quality on a scale from 0 not good to 100 very good for different performance categories of food retailers, like the food retailer in general, the product range they have, the services, the pricing, the location, appeal, and the communication. And then we can see what was in study 1 in 2019, and what is the score in 2022, and our results show not much change, but communication that improved slightly. Finally, for this lecture, cross-sectional designs. And it's not too much to explain, even though cross-sectional designs are arguably the most common approach. What you're simply doing, you're measuring attributes and of course determining effects at one point in time. And then a study, here an example might look like this. And again, 2 co-authors. And the study is about the relationships between organization commitment to supervisor, and servant leadership. Amongst others, we ask ourselves which effect do the facets of servant leadership have on the facets of commitment to supervisor. We collected data once in autumn 2023, and here you can see the results. The analysis was done by partial least squares path modeling, so structural equation analysis or modeling. And you can see that empowerment has a highly significant effect on effective commitment to supervisor, or that accountability has no significant effect on effective commitment to supervisor. Just have a picture of what is going on at one point in time. That was the research designs. The next lecture will be about inductive statistics. Until then, I wish you all the best, and it is bye-bye for now.